Maybe we will wait for a few minutes and then start the class. In the meantime, if anyone has any questions, I can take them. Okay, some clarification from last time. There was a question raised on uh, are member attributes, if there is no access qualifier, so let's say we don't define them as private or public, what will be the default nature of the code? So probably I made a mistake there. So the answer is that it will be private unless you explicitly define public. If you define something as private, it is obviously private. But if you define something as public, it becomes public. But if you don't define classes with member attributes as uh, any public or private, it by default becomes private. Okay. Right. So since classes and objects and such, this object oriented programming is quite crucial to C++. So I'll spend some more time today on discussing various aspects of this object oriented programming. Okay, so let's continue from last time. Uh, Today I'll discuss about the this pointer. Okay. Okay, so let's start. My bad, sorry. So let's start. Include IO stream. Okay. As usual, if we want to print anything, we use the IOStream header file. So I'll define a class called mm, just maybe not class, like my class. Okay. Then it'll have some variables. So let's say I define them to be public. Okay. Public variables integer, let's say x, integer y. Okay. So now I'll also define, so these are the class attributes x and y. Okay. I'll also define as a function, which also be public. Okay. So let's define the function. We'll take some values. Let's say integer a comma b, integer b. Okay. And what this does is, let's say it just sets these values, the internal variables. So it will set x as uh, a and y as b. Okay. This is allowed because a function. So this is part of the class. This has access to the internal variables. Okay. The x and y are the internal variables for the class, and it has access to them. Okay. And end this with semicolon. Yeah, semicolon. Okay. Now we'll go to the main function and then define this object for this class. So my class, I'll define an object called obj. Okay. And then access this what do you call the function. Since it's public, that should be okay. So obj dot function and then pass some values. So let's say 4, 5. Okay. If you guys have any questions, in the meantime, you can put in chat also. I will be monitoring that. Yeah. Now, okay. All right. So let's print this. Sorry, print these variables. So first will be since this I've defined them x and y to be public, I can access and then print them also. So something like this. Standard out the x variable, which will be objects x. Okay, and then end the line. Similarly, y. Okay, yeah, let's compile this. So out, and I'll use this CPP and okay. Oh, my bad. Yeah, yeah. So yeah, the mistake was to I declared it with a comma. It should separate actually with a semicolon. Anyway, you can declare multiple variables of same data type as such also. Yeah, it depends on the language you're using. Some languages allow this way, and then some others in a different way. In any case, so what I've done here is I'll show the this example. I'll move towards how this is useful in this case. But let's understand this example. In the main function, I declared an object of type in a way. You can think of it as like complex user-defined data type, my class, which is a class, and I'm calling the function of that object 4, 5. With that, then I'm printing the values, internal values, and function does. I think it's pretty much straightforward. What it does is it takes values a and b and then sets the internal variables. So far all good. Like I think this is straightforward. And the public to again reiterate, the class has public members x and y, and the function is also public. Hence we can like call it. Okay, so now we'll write the same thing in a different way, which will be like, yeah. So what this is, the keyword itself, what this, it might be a bit confusing, but what this does is, it's a pointer, okay, which holds the address of the object itself. So for me, the object is obj, okay. So that itself is the object, right? But for the class, like functions and all here, this keyword will be holding the pointer for that object. And how to actually, like, let's say use it. Okay. So what I can do is I can do something like this and then this. So the actual this keyword is a pointer. Okay. And then you access member functions by using the arrow key. If it's not a pointer and it's a data type is just my class or something, you can just use dot to access the member variable. But for this here, the data type is my class pointer. So something like you can think of like it is my class pointer. Okay, maybe this is it. My class pointer data type. For what it stores the address? It stores the address of this object, whichever you define. So internally, it will when you access this in any class, it will automatically know which object it is referring to, because you'll use that objects this only anyway. So it automatically knows. Now, what's the use of this? Now, here I have access to the because it's a member function, I have access to this variable x. Okay, but if I write access x this way using like the arrow pointer, I'm explicitly accessing it. Okay, so accessing, and here this will be implicit access. Okay, and here this is an explicit access. So that's a major takeaway here. Okay, now let's actually we can do go even further than this. We can print the pointer itself. Okay, so in the function, let's print the let's say this address, whatever address it is, the this pointer is storing. Okay, and just print this and then enter. Okay, now that's straightforward. Okay, let's see, compile and check. So yeah, it prints an address that this object actually stores. And let's check. We can actually check that also, that which what is the address that object is actually storing, right? So I can do like write another line where I say object address, okay, and then print. Okay, so object review. Yeah, okay, and then yeah, I think I could do. Okay, great. So if you see the print, so the address of this is uh, 16 CE with hex. So, and here also it is 16 CE and so on with hex. So clearly they are referring to the same address. So this is a nice feature of C++ where you access the object address itself using this keyword. Okay, so this is important, right? Now, why do we even use this, right? So, like I said, here you are explicitly defining which member variable you are using. So it helps distinguish if it's a member variable or non-member, right? Uh, I could just write X and Y because it has access, but writing it this way explicitly tells me that I'm accessing a member variable X here. And here, because I am not doing that, it's a non-member variable, the variable A, which the object gets. Object, I wouldn't say, the function of that object gets. Okay. Now, we already discussed state of the objects last time. Maybe I'll also recap this a bit. Okay. So last week's lecture also had some comments. Yeah. So maybe I'll just put them audience. So, right, as we saw before, like this is from last week. So as defining a complex number using the complex class, which will hold variables like real and imaginary, then it was initialized using this declaration, like putting values 0 and 0, and then another object. So first is the P1, second is the P2, and so on. Then using another object called line, which is a complex, it takes the data type complex itself, and then define the object of line L1 using the complex variable, complex objects P1 and P2. Okay. Then so on, you can define different objects of the class, right? Then yeah, this is what we also saw last time. So I had again the same complex number with a distance function where it defines the square root. Sorry, it defines the distance from the origin, right? Using it takes it since it knows the real and imaginary part, it takes those values and calculates the distance from origin. So here, like we saw before, the state of the variable is can also be changed. So we initially defined C1, C2, C3 using some variables, right? And then I changed the values of the real and the imaginary part. Again, here they need to be public. So you can, if you want to directly access and then what do you call it? Um, Change the values, the variables need to be public. But that's all. That's usually not always the case. We'll see how to deal with that. But the key takeaway here is that you access those variables and the state of the variable changes. So that's essentially the idea behind a state of the object. Okay, not state of the variable, state of the object. Now, okay, I hope that is clear here. Maybe you can run this also. Um, mm, mm, um, okay, probably it was some other code. Yeah. Let's not worry about the distance function for now. Yeah. So like we can see here. So the first for the first complex number, we printed 1 and 2, right? That's what we initialized. For the second complex number, 4 and 7, okay, that's what we initialized also. And 8 and 10 should be the case for the third. Yes, it's 8 and 10. And then if I print the values later again for C1 and for the C1 after it's changed, it is what it shows, right? It's 4 and 4. Now, this is essentially the idea behind the state of the variable. Okay. I hope this is clear. If you have any questions till now, do let me know. Okay. Right. So that is the idea there. Now, again, coming back to the access specifiers, private and public, why do we even use them, right? Why even have these values? So, like we saw, some functions because they have to be some attributes because they have to be private because they are public you can access them, but sometimes you don't want that to happen. Sometimes you want the class to just have certain variables just private and certain variables just as public. Okay, the main reason to do that is it segregates things. It keeps the code clean, and lot of the times when you have when the class is actually accessed by externally by other libraries or something, you don't want the whole you don't want other code or any other developer to have access to that some of the internal stuff, right? Because it should only be used by the class itself and no one else. So to segregate those kind of things, you use private and public. So that is essentially the idea behind information hiding. Okay, that's also taught in the class. So that's the main idea there. Okay, I hope information hiding, the main idea behind that is clear, right? So there are in a way two things. So public attributes should not decide the state of the object, and private member functions can be part of the behavior. Okay, the behavior of that object, whatever it's doing. Now, okay, that is, I think, fine. Okay, so what is another thing people do is to access certain member functions. Okay, so here I had defined them as public, but let's write the same thing but in a different way now. Okay. That's a very good. Yeah. I'll take the same code. Okay. Let's not worry about the distance, but I'll remove this. Okay. Now the declaration will make them like work. Okay. But I probably can't access that, right? Like, I think that is clear from the how C++ is constructed for classes. Here I have not defined any keyword for them or access specified, which tells them that this is public or private. Okay. But by default, if you don't specify, it means that these variables are private. Okay. So this actually should throw me an error. So let's go there and compile. Yeah, see, it as expected, it should throw error. It's actually also saying it's a private member of the class complex and I cannot access it. Okay. But let's say I want to modify certain things and I do not have access to that variable. Okay. So sometimes what people do is they write something called a getter function. Okay. Getter or set functions. So I'll write a get function. Uh, so it will be like void, or maybe its return type is itself double. Okay. Which doesn't need to take anything if I'm returning. Okay. And what this does is just returns get let's say real. Okay. It returns the real part. You can also use the keyword this and with the arrow operator, okay, to access to explicitly say that this is the this operator that we are using. Then like have the function return the real part. Yeah. Then similarly, let's do imaginary, okay, which will return image. Now stars. So instead of accessing them directly, what I can do is access c1 dot that function get real. And similarly, this imaginary will be the get imaginary. Compile. Okay. Oh yeah. My bad again. So again, this functions are also private. I should actually to access them. I'll put them as public. Okay. That should go. Similar to how attributes become private if you don't define, if you don't explicitly specify it, functions also become private. So hence I was not able to access. Okay. Let's see. Yeah, so initialize the list probably here because it needs the uh, I say it needs the constructor for that. Okay, we'll use the constructor to initialize. So it will be, let's say, double. Anyway, I was about to show you guys how to overload constructor itself. So maybe we can do it in one go. Only to imagine. Okay. Probably the same things. Yes. It's similar to this one we used last time. Okay. I'll probably use copy the constructor also. The destructor also, yes. So have the real part and imaginary part. Sets the values real and imaginary. Constructor is called. Okay, and then destruct. Okay, fine, all good. And this is, yeah, now, sorry. Yeah, this needs to be public. So maybe let's specify it actually. Let's specify private. This will be private, and this part will be in public because constructor has to be called, so it has to be in public. Okay. Okay, for clarity. Yeah. Okay. Which was the last code? Yeah. Okay. So like we saw last time, so we declared real and imaginary as private, and public functions will be the values that we take and then define this with some destructor. Okay. Now I'll write to access the same values. I've written some getter functions. Okay. And define this C1, C2 to a different way. Yes, Madhav, you have a question?
Sir, can you tell me like how to get a grasp in C++? Like I
Hmm.
have joined just now.
Oh, okay. I actually discussed some basics, but I can go over some specific topics you want, or like, do I start with just classes again?
I I only want like how to I know Java and like I have also worked on Python and C, but
Okay,
C++ like I couldn't able to get comfortable in C++.
I
So
see.
wanted to know how to get comfortable in that, like how
Yeah.
to manage to write programs in that.
Okay. So if you don't, so there are few ways. So if I just let's say calling main functions and then writing loops and if statements, I guess that is I am hoping that is straightforward. So that is what you have in C also. Okay. But if it comes to classes, like what I'm discussing right now, that requires a bit different treatment because these classes don't exist in C. Okay. So do you want me to discuss classes or?
Like in today's session, is it the first session today?
Oh, no, no, no. This is, I think, fourth week, fourth class. Yeah.
And like in today's session, what are we covering up? Can you please tell me regarding that?
Okay. So last week I started the topic of classes. Okay, in C++, and today I'm discussing the this pointer, the keyword this, and I'll also discuss static keyword also, and maybe move on to friend class and some other protected class and maybe those
Like
things.
sir, let's say I am taking this course with my college, so yeah, it's sometimes difficult to cope up with assignments. So like,
Yeah, yeah,
can
yeah.
you tell me how to do assignments? Like how to manage to do the assignments if we are just new to this language?
That might be a bit difficult, I understand, but again, this course also requires you to put the effort along with like for doing the assignments and understanding. I understand that also people had pointed out in previous classes where they say it's they have other courses they're taking and then with this NPTEL course also becomes a bit hard. I do understand, but what I would suggest is spend time going through the lectures, okay? And so it's like the lectures are also designed in a way it covers some topics and then uses that to go to the other more, let's just say advanced topics, okay? So start
Okay,
with
so like
classes. Yeah,
I am confused in one, like I have a doubt, I
sure,
am
sure.
confused in namespace and
Hmm.
iOS team. Sometimes we write using namespace std,
Right, right, right.
and sometimes we write std and colon cout.
Correct,
So
correct,
in some programs we don't write std and colon. We
right.
just write couts and
Yeah.
cin. So
Yes.
I was confused like
Why
when
is it? Yeah.
what is the right way of like using what is the need of using
Yes.
namespace?
Namespace, okay. So thing is, again, I had discussed this in previous call, but I can again discuss this. That's absolutely okay. Let me pull out. I think I have this file from last time. Let me just see if I have any discussed that in any of this. Um, yeah, pointers, vectors, and then inline. Okay, that's okay. I start with a very basic standard program. Okay, so here what I did was okay, the this is a very basic program. Okay, so I start with the include IO stream. Okay, so what this IO stream is, like what does it do? So it's called a header file. Okay, what's the header file? It just says that I can use functions like couts and endl and cin also. Okay, those functions and their whatever the code is the body of the function. It's defined. It's there in the object, and the header file includes that says that there is a function cout, and whenever I call it or something, I can use it. Okay, that's all the main takeaway from including this is. Okay, now what people do is they write functions like standard hello, sorry, void hello or hello with some arguments or something. Okay, I guess this part is clear. Okay,
Yes, sir. Yes, sir.
okay. Now to access those functions defined inside IOStream, okay, we use something called a namespace. And standard and these libraries are defined inside uh, the namespace standard. What's a namespace? Namespace is just a way of saying I'll define certain functions or certain class even or certain anything in my code and then separate them out. Okay. What do I mean by that? So let's say here cout is a function. It's accessed by standard colon colon, but forget that standard colon colon exists. It's essentially like hello. Okay, void with a hello, and then brackets are there, right? So you can just think like cout is also something like this. Okay, it's actually not. It looks something like this, uh, but for understanding, just think that cout is also something like void hello. Like this is a function, right? So cout is also a function. Now why do I need to use standard curriculum cout or anything? What happens if I don't? Now see, in the in any program, okay, this is also a little sidetrack, but just for completeness sake, I'm saying every program in C++ has to have a main, okay, and then it will take some values or it will take call some functions or whatever. Now here, if I want to call function like hello, okay, hello has to be defined first, okay. So here it says that here the code sees that there is a hello. Okay, it doesn't take any values or anything. Okay, great. Here also I'm not passing anything. So it will use this definition. Okay, and print the like call this function and whatever it does. What this function does is just print hello world. Okay, great. Now to do the same thing, okay, you have to also think again like what we did for main and called hello. Hello is also calls a function called cout. Okay, and endl and line. Now to know what is this cout, okay, I have not defined it anywhere here. I mean, there is, IOStream says that definition exists, but what is that cout? Like which cout is it? I can have, I can actually do one thing. I can define the void cout here also. Okay. And then like it won't be exactly looking like this, but roughly something like this. And then call this cout also. But how does my code actually know that which cout to actually call? Hence, we use namespace. So standard namespace itself has this function cout. You can actually do one thing. You can actually have your own namespaces, okay? Like defined like under some namespace, they give your own my namespace. Okay, and then put your code inside, like whatever functions and everything. Maybe your own cout somewhere here. Okay, and then you can use my namespace. Okay, instead of standard cout, my namespace, and then cout, and then put all it. I mean, of course, it requires a lot more code to do the same thing, but I think this should be the main idea. I hope that is clear. So the main thing to use namespace is to actually avoid collisions. Name collision is what it's called. You can have, let's say, for some function hello or some function cout even. But the issue is that if you don't specify the namespace standard, it won't know that it has to use the standard cout defined inside the standard library under the IO stream header. Okay, I hope that is clear. Yeah.
Okay. So sir,
Yeah.
like just say, if we define namespace above,
Hmm.
so
Yeah.
it does not require namespace to be defined in the function, right?
Not exactly. So what this line did was it declared something called a namespace, and then I defined some of my function. So I can have like void hello. Okay. Yeah, and function. And here what I'll do is instead of printing hello world, my namespace. Okay. So this function, I'll clear it a bit. Yeah. Right. So inside this namespace, I declared some function and then uh, like enclosed it. Okay. So now thing is to access this function, I think it might throw an error because this has been, let's see, I think it should be okay. So here I can access hello because I don't need any, or you can do like, I mean, this is in global scope for the function main. So here you don't need any namespace for hello function. But let's say I access hello namespace. This is one function I accessed. Other function is, I think this should work. Let's try. This is in week one. Okay. Okay. Then I, yeah, I think what is the error? Hmm. Yeah, it wasn't able to get no by space out.
I think line 11 has issue.
Oh yeah, I did not close it actually. Const expression. Oh yeah, const expression needs again. That's a C++, I think 17 feature or something. You have to actually specify to for it to compile. It's not there for this default. Again, this I covered. These are the examples I was using for uh, teaching in the class. But anyway, for
Yes,
this,
context PR doing CONSTX.
yeah. So okay, these are some data types which are inbuilt to C++. So you have character float and integer and all. Those that is fine. So like here I define integer. There's one more qualifier which says if my variable can change or not. So if you don't define anything, so imagine this integer left to that, there's nothing. So if I just define integer a, okay, let's say I define integer a equals to 0. After a lot of, let's say there's a lot of code, okay, I'm just representing by this comment. Let's say there is a lot of code, and after that I want to define a equals to 7. Okay, this is perfectly valid because I can change my variable. Okay, but let's say this was defined as const. Okay, so what this means is the variable a cannot be changed. Okay, once it's been initialized and declared and initialized, it can't be changed. So this will throw you error. You can't change a to be 7 later on. Okay. The extra feature that was added in C++, I guess 17, is that you can instead of just const, you can have const expression, which means that during compilation itself, the variable a, which is an integer, is set to 5. Obviously, it can't be changed because const expressions also are constants, but there's an extra uh, constraint that the variable, the line itself, wherever you use const expressions, they need to be compile time constant. Here it is. So just to show const expression and how do we use C++ 17 features, I had this line. Yeah,
And like, why is it giving error in this line?
const expression. Yeah, because G++, the version that I'm using right now in this compiler, the default isn't using high versions of later C++ standards. So this requires C++ 17 standard. So I believe I had that line. So standard, I think that is, I forget. Yeah, so you have to do something like this. You have to include hyphen hyphen standard and then say which feature you want to use. Of course, your compiler should be should support that standard. So I want to use C++17 and then compile the hello CPP. Here it is okay, I think. Yeah, this like I said, this should throw error because a is like defined as const. You can't declare them later. So again, compiler will help you there. So let's say compile comment this and then let's compile. Yeah, compiles perfectly fine because I'm not changing a later on. Okay, that was the main idea behind const expression. And yeah, that's it, I think. Okay, let's run the file. So now what you can see is uh, I have two hello. Okay, so one hello is in my namespace. Okay, and which is a function. Another function is hello. So this hello will call this function hello, which will print hello world, which it did. But this my namespace hello will call this function inside the namespace hello. Okay, and hence it prints the my namespace hello world. Okay, right. Now the main thing I want to like I would say the key takeaway here is that the namespace, this namespace, whatever name you give. Here I gave my namespace. Okay, whatever name you give, and then you with double colon, whatever you're trying to access will be inside that namespace. Okay, what this essentially did was I have function hello defined. Let's say instead of actually being here, it's in some other file, which is what actually happens when using IOStream. Those functions like cout and all, they are actually defined and they are there in some other files. We are accessing by using these header files, like we are accessing those functions. Essentially, think of it like, let's say this my namespace whole code from line 3 to 7 was there in some other file. And I want to access some specific function of that namespace, which is hello. Okay. Now, how to do that? I'll use the full namespace, give the namespace actual name, access using the double colon, and then access the function. Okay. I hope this is clear. So the idea is that to access a specific function of under some namespace, we use the namespace. This is what even standard does. Now, coming back to your question, where people use this something like using namespace std, what this does is it automatically says that whatever functions I'll be using, if you can't find them like in global, so this is in global scope, hello, and this overloaded hello, both of them are in global scope. Again, this is also in global scope, so I was able to access. But the point is, if I'm accessing some function which is not there in this global scope, I should look at the namespace standard also. I don't need to actually, after doing this, I don't need to explicitly say standard cout. I can get away with just saying just cout. Okay. Now, I hope this is clear. Why
So
use
like
the
what will happen if a function name cout is already there? Will
yeah,
it be clashed, or will it get
exactly.
will cout work?
Yeah, then it will be a clash. So when you say it's an namespace standard, so which it doesn't know which to use, right? So and also it's also a big source of bugs and errors. So actually, this is actually not recommended doing in production code. Malab, uh, unless it's a very internal function and those classes are very internal to your code base or something, and very few places. If it's a global scope or something, then you always uh, use the full namespace. It's actually good practice in a way. You can think of it like it's a good practice to always give the full namespace because you know what is the explicit function you are calling. Readability is more important than having bugs. So
And I just wanted to ask one last thing, that I
yeah,
usually get confused in these Angular brackets in cout and cin.
yes,
So like
yes.
how to remember this, like where to put which Angular bracket?
Okay. So this is more of a how do I put it? How it's constructed, I can probably say how why it is even done. Okay, so think of in C++, angular brackets. Okay, so if it is just single, let's say just a single bracket, it's a compare operator. So let's say a less than b, it will compare and return a boolean. It's true or false. Okay, that is the job of single angular bracket. But if it's double, it's a bit more different. What this does is it does bitwise operation. You can, if you're not familiar with bitwise operation, you can look them up. But essentially, it is numbers are represented using binary, and using this operation, you can do some using this operator, you can do some operations with them. That's it. That's the idea behind bitwise operation using angular bracket left side or right side even. So double angular brackets, both left and right, have certain kind of operations which act on binaries. That's it. That's all. Now, building on that, what actually happens is standard C out when you give this angular bracket, and then let's say you have some text, some string. What it does is actually streams the bits to standard C out. That's actually what happens. Again, finally, after you can think of it like after this your string is done, you're giving the standard E and L. So that's like end of the line. So whatever the command for that will go. So standard C out is essentially your computer, um, or let's say it runs in some operating system, right? So it goes to the RAM, then RAM. So your code gets compiled and gets um, stored in the RAM first, and then from RAM the CPU accesses, and CPU sends signals to different peripherals. So let's say it's a display. So see how it will go to display because that's what we want to see, right? So it goes to the display like this, my terminal here. Here it's the terminal. So it will stream these values. Okay, using so hence the double brackets. It's essentially doing bitwise operation by streaming these values, but you can think of it like it's required. It's also a syntax for using cout and ENDL and so on. Yeah.
Okay,
Similarly,
sir.
yeah.
Okay, sir.
Yeah. Sure.
And
Similarly, if you
like,
have scenes, then you do something like the bracket. It says the opposite. So from C or like let's to be more consistent. So standard scene will take input from the peripheral, let's say keyboard or something, or file or whatever, like from the terminal, and then put the inside variable a, which we defined, not with constant expression, but whatever. Okay, I hope this is
yes,
clear. Yeah, yeah.
yes. And like
Okay.
classes are
Hmm.
classes took place weekly or bi-weekly, just to confirm this.
Oh, these sessions are weekly, once per week. Yeah,
Okay, okay. At same day.
yeah. Every Tuesday, 6 to 8. Yes.
Okay, okay. Thank you very much. Thank you, sir.
Sure, sure, sure. So I'll repeat this part again. So for this TA sessions or something, uh, it's not exactly compulsory to attend, but if you have questions, if you have any topic that you're not understanding or any clarification required, anything, you can just attend and ask me to explain. This is in general, I'm saying for everyone
And
also.
also, like, is the recording of this session are available to us or something?
Yeah, yeah, it's available. So I'm recording these sessions and they will be uploaded to YouTube, and you should guys get a link. So NPTEL actually handles the that part. So do let me know if you guys are not accessing, having access or something, because
Like, we
mhm.
currently don't know on which channel this will get uploaded.
Yeah, no, so you should get the link actually. So uh, for every this session, there should be a link available. It's there in the single channel with the playlist, but if you don't have access to any of the lecture or anything, just I would suggest maybe write to NPTEL support or something. Maybe they have access to that. Yeah. So that is one thing is what I would say. Because they actually combine everything and then give you guys. So else I can put them in the chat also. That's okay. That's if you guys are okay. Yeah.
Okay, sir. Thank you very much, sir. Thank you.
Sure, sure, sure. Yeah. Again, like if you have some very specific questions, I can take them, or else usually I'll cover some topics from the lectures itself. Because it's like doing them live or something, then you get the actual coding. You actually see what's actually happening. So hence the idea. Yeah. Okay. Great. Um, yeah, just do this. Okay. Yeah. So that's the part for C outs and all. So remember after uh, so it's like again coming back, I'll just it's a bit side thing, but so things like angular brackets like this, double angular and all. So in CUDA you have triple angular brackets. Stuff like this are like uh, part of the standard. Is how it was defined, and some of them have actual how do I put it, reasons why they were done so, but after some time you can actually just think of it as how the language evolved and how the actual thing was defined. So you can think of them for now just as syntax if you don't want to go into very nitty gritty. But what I would definitely recommend is understanding like from starting from basic codes like this. So um, know that any function, in any C++, you have to have a main function. You can define it as integer and then return 0, or have it void, or give it arguments. So it can take arguments from the terminal also, any of those things. But then you should have a main function. It will then perform the code. It can call other functions which you have defined, or it will call functions from some um, standard header files. That's the main idea. Okay.
Okay, sir. Thank you.
Yeah. Okay. Maybe then I'll continue with the class part. Yeah. To because you're attending today, I'll just maybe summarize a bit what I've covered till now. So here I was showing about how to write some basic functions like hello and so on, like basically printing, declaring some variables, some characters, and so on. Then um, to use uh, something called arrays. So C itself has C style arrays. You might have seen them something like C. So let's say integer a comma a with bracket 10 or something. So it defines a collection of 10 numbers of data type integer. Okay. So this is what people do in C. The C++ way of doing the same thing is this. Okay. That's maybe you can go back and look at the example again. So that discussing some discussion on pointers. Okay. And let's go this maybe. Yeah. Hello world. Discussion pointers, like understanding what pointers are actually. Okay. Then similar idea is to use sorry vectors. They're very similar to arrays, but there's a big difference between them is about the allocation. Arrays are um, stack allocated and vectors are heap allocated. And with C++, working with them and working like defining and working them becomes much easier. So that's something you should be. These are some data types which you will routinely use. So hence I discussed that. So vectors, arrays. Last week we moved to classes, and then some discussion on inline data type. So inline keyword. So what does inline actually do? And some stuff like macros. So these are also this hash include, hash define, and all. These are called macros. They have different properties depending on how you want to use them. So this is something we discussed. Okay. Yeah, classes. So last week we saw something on classes. So like you can think again, I'll reiterate for others who are joining. So classes are essentially user-defined data types. Okay. So you can have data types like let's say integer a equals to 0. So this is a built-in data type, which just means that this is the variable a is an integer. Okay. And the value it stores is 0. you can actually have more complicated and user-defined data types, which are essentially just called classes. So instead of just integers, let's say real numbers, I want, sorry, not, these are integers. I can have real numbers defined by like how much precision I want. So double has more precision. So I'll define double D equals to again 5.0 or something. You can have floats and all, like depending on your precision required. But essentially, the idea is that float and doubles represent real numbers. So there is no um, actually like inbuilt data type for complex, but I mean, you have now, but let's say you want to write your own complex data type, at least in C, I don't think there is. So what you do is you define, oh yeah, yes, go ahead.
Sir, class line has P1 and P2 as object. मतलब class line has member data P1
Yes,
and P2 as object of complex class.
yes. That's that was the reason behind this. Maybe I should start with no, this was something else. Um, just give me a second. I'll pull out the other file that I used started with. Huh. Yeah, maybe I should look at this one. So here we define something called complex. Okay. Forget what public is. Don't worry about it. So it has two members, real and imaginary. Okay. Now what we do is in a complex in a class, we have to first declare it as an like it should have some object. Okay. So you define so the way to do it is so C1 is the object of data type complex. Okay, which is the class. Okay, and it is initialized. This is one way of initialization because there's something called, I also discussed about constructors and destructors. So those things currently I have not explicitly written, but think of it. So, but then C++ has default constructors. But think of it like for now, a very simple basic way of writing the class is what I've done here. Okay, and I have to define them as public here because otherwise they will be private. What's the difference? Now, when you have an object like this, you can access its variables, internal variables, if they are public, like this. Or if they aren't public, and let's say they are private, you can't. That's the idea. But let's get back to defining it. So a class here, okay, is like you can again think of it like a data type. So we usually start with the data type and then the object, right? So here essentially the same idea. Instead of did I have it here? Yeah, instead of some data type and then the object, okay, equals to something. You can think of it like this is also like a declaration. This is like initialization, okay, both declaration and initialization. So for classes, you can do something like this. Sorry, uh, object C1, and I define the values as 1.2 and 2.2. So they will be set as real and imaginary. Okay, there is a better way of writing the same code. This is just for illustration. Then here you see that this is like a how do you put it? A complex name, but it's also a data type. Okay, that's the main use of classes. You can define more complicated data types, and then according to your code, you can then move on. Okay, so here I'm showcasing more complex objects. So C1, C2, and C3. First is with this point 1, comma 2, then 40, 47, sorry, and then 8, 8 and 10. Then to access them and print them, so we use standard C out and all with then you do dot and then real. So what it means is for the C1 object, access the real variable, which is this, and it will accordingly print. Okay. Now you can have functions also.
Class complex is by default private or public.
Class complex itself is it has to be, it's in the scope, right? That is in public. You
Okay,
can
but like I have heard that if we don't define public statement, it by default gets private.
correct. That is for the member variables. You're right, but that is for member variables. So
Okay.
what the like what I've heard is essentially this. So if you don't define public and for a complex like this, let's say this is a class and define variables like this will actually, and if I compile and run this, it will throw an error. Let's try this out. This is in week 3 of, sorry. assign this class. Okay. So let's put this first. Yeah. So like I was discussing, it will print all the values. That is okay. Like real, imaginary, so on for all the objects that we defined, C1 to C3. And then for what I did was I explicitly access those values, imaginary and real, and then change them. And then let's print them. So this is one way of changing this. It's called as changing the state of the object. Okay, this is one. But like asked, what if this was not public? I don't define any keyword, nothing. I just define a class and then declare the double and imaginary. Then what happens? Let's see. Will throw error because now these variables are private and I'm accessing some private variables here. You can't do that. That is not allowed by nature of how class is um, in a way that the standard is defined for C++. Yeah. So also the compiler says these are private members. You can't access them. So if you don't put the keyword explicitly, public or private either, it is by definite by default it will be private. So that's for the member variables and the member functions of the class. Okay. So here,
This is the
mm,
this is not for a class, like public, private keyword are not for class, or like
you
protected
can.
keyword, or
They are also. So when you have derived classes, so the class that is being derived from that has to be public, right? So otherwise you can't uh, derive it. Yeah.
and
Other example, I think a better example will be here. So here, what I did was I used the data type complex to make another like use it inside another class. Okay, so this has to be accessible, right? If I don't have complex data type accessible, I can't do this.
so like we have didn't mention any keyword here for complex
Mhm.
class. So
Mhm.
by default it is public, or like how it is accessible in line class.
So for here, it is in the global scope, so it is accessible. You can think of it like public, but calling it public here is not exactly how would I put it? It's
If we
okay.
try
It's
to
okay.
access a complex class in another file, like beyond class2.cpp file,
Yeah.
we try to access complex class by making an object. So will it give an error?
Yeah. So thing is, it has to be first. The definition should exist. So what you can do is you can have these things in a header file or something, and then include that header file in class2.cpp and that file of your choice. So think of it like because these definitions should exist. So these are like um, think of it like all the things that require to make complex class complex like that itself. So I need two variables and I've defined them as public. So this whole thing, oh, sorry, I think that yeah, this whole thing describes the complex class completely in a way, well, for my case at least. Now, if I have another file, how does it know what is the complex class? That definition is here in this file. So in those cases, you have what people do is include in some header file, and like instead of hash include iostream, you can have something like hash include uh, complex dot h or something, some header file, some whatever name you give. And inside that you can have this definition. Then obviously you don't need to include it here. Okay. And include this header file in your other file also, and then compile them all together. That's actually the reason we see this hash include, because those definitions and sorry, not definitions, the declarations are there, for the functions are there inside these standard header files, and we just access them. The code of it is in some object file which we link, but that's a different story. Yeah, hope this is clear. Yeah.
Okay, sir.
The main idea, okay, yeah, thank you. The main idea is that your whatever you call in your main function, it should have access to it. That's it. Now, what's that access? Now, these are in the global scope in a way. I mean, the scope is outside, so they have internal to main, which are in these curly brackets. They have access to this function, these classes. That's all. That's the main idea. So I can access complex, both, and line also. Now, it's true for not only classes, functions also, static variables, anything, like whatever you want to call. For all of them, it's the same story. It has to have access. Is it in the global scope or in the local scope or anything? It has to have access. Otherwise, it doesn't know what to call even complex if it doesn't know what is it. That's the idea. Okay. Yeah, like we were saying. So there is a function called there is a keyword called this, which we can use to access the address of the object. Okay, so my class is again a user defined data type. Here it doesn't do anything interesting. It just takes some it declares some it has internal variables. It has a function which just sets them. Okay. Okay. Initially it doesn't do much anything interesting, but to understand the concept, here I'm explicitly explicitly accessing the variable internal variable x, saying that this is actually part of part of my class, and I'm setting it. And it helps in, again, like I said, segregating your member functions from non-member functions. It's actually not required here because a class has access to its internal members, be it public or private or protected. Yeah. So here, oh yeah, you
Is
have a question? Yeah.
C++ a pass by value language or pass by reference language?
Pass by, sorry, what's the question?
C++
So
is pass by value language or pass by reference language?
you can actually do both. So that also I think I discussed. So let me see. Okay, one thing I can show you here itself. So because I have a function and I have defined integers like a integer b. Okay, here it is inside a class, but in general also it's the same idea. So when you have functions, and let's say I define function with 4 and 5. Here I've explicitly uh, pass the value, but in case, let's say I have integer a equals to 4 and sorry, and integer b equals to 5. Okay, and pass, instead of 4 and 5 here, I pass a and b. Okay, one will see this and say it's the same thing, right? It is. It essentially does the same thing, but what happens is I'm passing variables here. Previously, I was just passing actual specific values. Okay. So compiler knows different optimize. I mean, again, depends on the flags and everything. But for now, think of it like I have variables A and B, which I passed. Okay. Now, maybe change the name actually to make the pass more concrete. Yeah. Maybe pass PQ. I call this PQ. So I'll pass variable P and Q. But here, sorry, just give me a second. Yeah. So like I was saying, I have variables p and q. Okay. When I call this function integer a and integer b, what this does is it copies the value stored in p, okay, and copies to a. So that's the pass by value. There is a pass by reference also. You have to uh, put an emphasis. So the difference is that your variable, you have a variable in the stack frame, okay, p, both p and q. But when the stack pointer moves to function, it here it will see that it has a and b, right, as parameters. So it will copy the value of p to here, okay, and again for q to b. Use this values here because I need access to a. So it will copy them. Then this is removed, right, like destroyed, because there is no a and b required after this. Okay, that's the pass by value. But if you pass by reference, so which I'm specifying by this ampersand, what happens is the actual uh, A, in a way, you can think of it like it doesn't exist. Whatever I'm calling A and whatever I'm calling B are the same thing. That's the pass by reference. So essentially, it's the same variable. We in just it's just that in different places, it's just um, called like shown by different names, but essentially for the program, they're the same thing. And then when you modify, let's say A here or something, and then it also gets modified here. And if you try to print P or something, that's the pass by reference. C++ has both actually. You can pass by reference and pass by value.
Okay, sir. So like when to decide that we have to make our function pass by reference or pass by
Pass
value,
by
like
value. Yeah, it
how
depends
to.
on a code, like basically what you want to do. So let's say I probably have some functions from last time. Let me see. Ah, yeah. So something like this. What I did was, yeah, I have a function main. Okay. Yeah. This is actually the reference file. Okay. Then. Okay. 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 So let's take this example to understand what is reference and pass by value. So for example, I have defined some size 5. Okay. Now the nice thing about C++ is there is a thing called standard vector. So what this does is it allows you to dynamically have storage depending on your size. So I've defined 5 and I pass this size here and define something called A. This will be standard vector, and these single angular brackets are called templates, which we haven't covered yet, but just for now know that these are something which you pass and which tells that whatever the is the collection of values you are storing, which is like let's say size is 5, so I'll store 5 values now. Like create it will be created in the memory. They'll hold integer values. Essentially, that's the idea here. That's what it means. Now what I'm doing is writing a loop for loop. Okay, starting in 0 less than the 5, or I can put actually size here. But anyway, it doesn't matter. Uh, then I'm storing each value as I. Okay. Now, accessing the each location, I use the bracket operator. Now, I think this is clear. This should not be uh, too confusing. Okay. Then I use pointers here. Okay. Then I use functions. Yeah. Okay. So now what I did was I accessed the this is the declaration, and again the storage is also taken care of here. Then here I'm initializing each value for the vector. Okay, so this is like before starting my actual work, let's just say this is what I did first. Okay, now there are two ways I can access the values of this vector array. Let's go with the reference way because you asked. So what I'm doing is I'm passing the same object here. Here again, the standard vector is actually a class. It's under the vector class. So you can see that it has allocator and main things. It's under the standard class with standard, and then a lot of namespaces. But essentially, it's under the namespace standard, and it's a class. Templatized though, but ignore the template for now. Here it takes the you define with some object, okay, and then it has overloaded constructors. So one way of defining the object A for the vector class is just pass the size. So if you pass just one argument, it knows that it will be for the size. Okay, now this object A I'm passing to a function fn. What is that fn? Now fn I have two actually. So if you see q and a, q is a pointer and a is the object itself, right? So so I have two overloaded functions here where uh, actually this yeah, I don't know why I defined it as a void, but integer, but void will also do anyway. So because I'm not returning anything, it's a good practice not to declare them with some data. Anyway, that's a side thing. Now look at this function. So I have function fn. I declare the data type. So it takes a standard vector integer. You have to for even if the template is how to put it, um, it has to be defined. So it explicitly says that this is an integer data typed standard vector that actually gives the full data type. So again, think of it like you have built-in data types, like integer, double, float, and everything. The whole thing standard to here is also a data type. User defined or maybe user created, it might be custom data type, but it's still a data type. Okay, again, that's defined under standard namespace, but anyway, we're just using it. Now with a ampersand, what I'm doing is I'm passing by reference. What this does is it takes the value, takes the object A, okay, here, and then using the bracket operator, I access the values, double each of them, and then print. So we can see this. Is this an this is an Then I compile this file. It's, yeah. So ignore the first one. So the B part is what I'm printing. So A, sorry, it prints. Yeah. Okay. I think it is clear if I haven't printed the values of A, but it will be from 0 to 4. Okay. Then I'm calling this function f A, which doubles each of these values, right? This one I don't look at here. So where one other is commented. So because I was focusing on the second one anyway. So here I'm passing the value, the object by reference. Okay, doubling each of them, then I'm printing the values. So if I print A also, maybe let's just do that anyway. Will be after yeah. So before fn, the values were 0 to 4. Okay, then I call fn. Because this is passed by reference, the actual object also changes when I try to modify the location. That's the idea behind passing by reference. So that you can, like I said, passing by value or reference, right? So if you want to actually change the contents of the object or you want to modify that object anyway, like in any case, whatever is the code required, where you want to do. Here I want to actually change the object, so I pass by value. If I hadn't, let's see. Here, note the outputs. So before passing the function, it is 0 to 1, 4. And then, yeah, inside B, when it's called, it doubles them. And then after, it is changed. Okay. From whatever is the output that B is printing, A is also printing that after it, because A is also modified. But let's say I remove the ampersand here. Yeah. What you say is it's back, it's actually the same values as the original. It's not the modified values. So the main difference is that when A was passed here, okay, the function f n here, it creates a copy of A because the same data type, it creates a copy and it's like a new standard vector integer B, okay, doubles it, prints it, and then just destroys it. This B after this function gets called doesn't exist. It does its job and that's it. Then when you try to when let's say I try to print A, it prints the original values it was stored. That's it. But if so this is pass by value, or basically it's like a copy that happens. But if you pass by reference, okay, then essentially the idea is that the object A and B are the same thing. They for the operating system or the code or anything. And when you modify B, A also gets modified. Okay, that's the idea. So depending on your use case, you can pass by value or pass by reference. You can also pass by pointers. So So it's not called pass by pointers, but you can pass the pointers also. The idea is that you want to change the value. So again, this is something you can also do. So there is a thing called there's a member function of vectors, which is called data, which gives you the raw pointer to the starting value. Okay, so A is a collection of integers. So if I want to access the first address, I just do this. I just do a dot data. It gives and store it in some integer pointer q. It gives me the first pointer to it. Then what I can do is I can just call another write another function q, pass the pointer to it, and which will call this function. What this does is it prints the values. You can again modify it also, but here what I'm doing is accessing each of the values by doing a dereferencing. So if you use the star operator on some pointer p, it's actually here in this context it means dereferencing. What is dereferencing? Now you have a pointer and then you shift it by some integers because these are I want to access the next value, and next value. Whatever is the value stored in that address, to access that you use something called a dereferencing operator. And again, the natural question is again, these are all I've discussed, but just to uh, there's a question, so I'm just again reiterating. So how does it know which how many bits or bytes it has to move? It knows from the data type of the pointer. So since it's an integer pointer, compiler knows that byte like usually these integers are 4 bytes. So it will know how much byte it has to move and then access the value at that address. Okay, I hope this is clear. If you have any other questions or any more um, things that require clarification, I can take that also. Yeah.
Okay, sir. Like
Yeah.
here we included vector
Mm.
file, है ना?
Yes, yes.
So like if we don't declare it,
Mm.
it will give error, right?
Correct.
So how to include all files? Like is there any asterisk or something here, like hash include asterisk or something?
Uh, Hash include?
Asterisk as star for including
Oh,
all
okay.
the vector
Loading
file.
all. Okay, like in Python, I see.
Yeah,
Um,
yeah.
Not exactly because in C++, because of the way it is written, for all things you actually have to do it yourself. There is a lot of things which happens that way. It comes from C, and that principle has carried on. So if you want to include some function, if you want to use some functions, you have to include its header file from the standard library.
So like
Yeah.
if we write hash include star, will it give
Uh,
error?
yeah, it will give error. It doesn't mean anything.
Okay. Because I was thinking like how to remember this header file, like vector header
Ah,
file and
yeah,
different header file. It
different
would be
header files.
better if we could access all the header files at once.
Correct. But think of it like while runtime. So the one of the reasons people use C++ is it's quite fast. Okay, very nice. That's what you have heard everywhere. The reason for that is because it gives you control. Okay. One aspect of C++ is also compilation. That obviously you can run something, but before running, like what I'm doing here is compilation, right? So let's say you include all the header files in standard library. The compilation will be huge. It will take a lot of time for it to compile also because it has to um, include all the functions, like make the symbols for it, compile, like include everything. So okay, maybe I'll tell you what happens when you do this hash include. So let's say instead of this, I did hash include. Uh, use this. I will use heap vector dot cpp. I can do this. That's absolutely okay. So what it will do is heap vectors dot cpp has some code. Okay. Do I have some huge code? Okay. Maybe this also. I have a class dot cpp. Okay. I can do that. Then class dot cpp. What this hash include is also a macro. What this essentially does is when your compiler, my compiler is G++ here, when it sees this code trying to compile, okay, I've given reference.cpp, it will see IO stream, a huge line of code, it will just copy paste it. this line one is replaced by that huge code. Similarly for vector, similarly for here. So heap vector dot cpp will include this whole thing, everything. It'll just take that and copy paste here, and then class dot cpp. And then there are some other macros, let's say, which are defined. It will do all of them will be processed. So hence those are called preprocessors. Then compilation happens. All this after including huge number of include files and everything, it'll start compiling. And imagine how much time that might take. There'll be a lot and lot of files. It has to make symbols for everything inside this header file you included, and then whatever file you have written here. Okay.
Like sir, in other languages also we don't generally include header files. So
In
why
Python,
C++
you actually do.
why
You
C++
do.
is fast like?
That's what. So one thing is because let's say I don't require vector, I don't need to include it. So my that's one there. Here the thing is you are gaining in compilation also. Why is runtime faster? So there are two things to it. So one is the compilation. Again, Python also gets compiled. There is a bytecode which is generated. It's, okay, that's a different thing. But anyway, the point is there is a compilation aspect to it to make it faster. So only you include only header files that are required. Okay. Now, to answer your question, being fast, okay, maybe I'll answer that. And the other question you had was, um, even I'm forgetting, how to remember,
All
right?
files,
So,
all files.
yeah, so I would say it's not really that difficult. So let's say you want to use vectors, you'll include vectors. You want to use arrays, you include arrays. Like stacks also, you can make a stack. So since these are all already defined, you can actually look up. I mean, with practice also you'll remember. But let's say you want to use some custom data type, like custom classes like this, some already built-in data structures. So those you can just look up online and then see how it comes by practice. It's not there are not many that people use regularly. So some which are used very regularly will be like IOStream vectors and all. So yeah, that's what I'll say from that side. The other thing is why is sorry, yeah, why is C++ fast? Okay, so again in Python also you actually do include header file. So you do import, right? Import numpy. Actually is including the header file. That's essentially it. Uh, and then what you can do is from that huge library of numpy, you can do from numpy import something, right? So that's like only importing a certain section. What happens is you can actually try this importing numpy or importing something, a subsection of it, and the compilation will be much faster. So from compilation perspective, it's always good practice only to include files that you're actually using. Okay, that's from both from Python and C++. Now, why is the C++ fast? So in Python, there is a thing called garbage collection. Okay, what it does is automatically, so let's say you don't have to define some data types, right? So it automatically sees if some object here, so let's say A or I or anything, it'll keep a reference counter. Okay. I'm not going too much into it, but the idea is that it will keep track of when my object is created and how it is changed and how it is destroyed. The language, it is built into the language. Okay. In C especially and C++ also, it's you who has to take care of that. So for example, yeah, here I declared something called a pointer A, okay? And using the new keyword, I myself asked uh, the uh, from the program, I asked the operating system that I want this to be allocated, this data. I mean, I have not, this is uh, this is one way of declaring, but imagine like what I'm doing is I'm asking the OS give me some data storage so that I can store some values. Okay, I store some values, print them. Okay, then I myself have to explicitly delete it also. Okay, so the new and delete keyword again, why I'm using this are because again, coming back to something a little separate, which is like stack allocation and heap allocation. Stack allocation is fast memory, which is on your CPU cache. Okay. Now, let's say you want very large, like lot of data, large amount of data. It's not just 5 year. Let's say like 5 trillion or something. Now, that if you do it like try to just do integer a then bracket 5 or something, it will just throw you stack overflow, because stack has a limited capacity. It's like 20 megabyte or something. I'm not entirely sure. It depends on the program and operating system and everything, but it has a limited memory. And let's say you want to have much larger memory that comes from RAM. Okay, so to have your data structures on the RAM, you in C and C++, you have to explicitly ask for it for the memory. Okay, and it's the job of the programmer to explicitly ask and delete it. Okay, this is why and it's not left on the programming language itself. Okay, which is what happens in Python. This thing happens automatically due to the garbage collection. In C and C++, you have to do it. Okay, hence it is much faster because you are explicitly in the control of all the data. The It's not all doom and gloom in a way, because in C++ also, because of this mm, the how scope happens and everything, you do get a lot of benefits of I wouldn't say it's garbage collection, but in a way it kind of is. So for example, yeah, just take this example. Same thing, but with the vectors, what happens is I can just define like let's say a. I haven't defined its size. Okay, so if you print its size, it will be 0 because I haven't given any bracket. What I can do is I can access a function called resize. Okay, and pass 5, which essentially does what we saw here. Yeah, this no, which essentially does what this line does. Instead of just passing size, you can actually resize it later. Again, this is heap allocated, so you can change the size up to your wish. Then if you print it, it'll print 5. I store the values, great, and then print them. Okay. Now what happens is, since I've declared this inside the scope of main, which is this two brackets, okay, curly brackets, and when it reaches here, out of this scope, A doesn't exist. So because A is a class, here its constructor was created again, like it what we discussed last week also. Its destructor gets created here, gets called here. Okay. The nice thing about it is that destructor will delete all the internal variables or whatever it was declared and everything. So in a way, because of the scope of C++, the memory management becomes easier. You still have some things you do explicitly, which again, we should not lose performance. But some of the things about keeping track of memory and all, automatically gets inbuilt in C++, especially if you use classes like this, standard classes. All of them have destructors. So a destructor always gets called when any of the object of that class gets out of scope. Okay. I know it's a long answer, but again, the uh, language has been around for a very long time, and it has evolved. So it has very nice features like this, hence the course modern C++. Yeah. Yes. Yeah. Go ahead. Go ahead. Yeah.
Does a header file include any memory or something?
Um, uh, if I'm being pedantic, I would say yes, because let's say you are writing a character, even A, in a file that will take some memory, right? Uh, so
As you
in
said, like it affects the compilation speed.
yeah.
So,
So yeah.
like, does the header file include any memory or something?
No, so technically, I mean, if you consider the lines of code as memory, then yes, it includes all the header files include memory, which will be, let's say, even if they are like 10,000 lines of code and anything, till that file itself have some memory. That is fine, whatever. the actual uh, compilation gets affected not by just the memory of the lines of the code or anything. No, no. What happens is, because you included the vector header file, like I said, if I include hash include q1.cpp or anything, it will copy the whole content here. Forget the hash. I mean, okay, you can include the hash include also. So that with all the code it has here, it will get included. Okay. Now the next step is the compiler has to compile all this. So functions like main, and I have functions, I don't have main function, but let's say I have functions like fn. So fn with like at parameter pointer p function with this taking this data type, it has to make symbols, and inside each function it has all, let's say, a large amount of code. This compilation it has to do. So the larger code you have, because it has to generate assembly language, assembly code for all this, right? And then convert them to binary. So that is the time that is what actually takes the time. Compilation of all this code in when you include header file or include any file actually. Oh, sorry. So to uh, go even bit beyond, what happens is it doesn't. So header files generally don't have the body. Okay, I'm sorry. Yeah, don't have the body. They have just imagine the everything inside the brackets are just not there. Okay, it just says that this function exists. The body is
Basically,
actually,
it's like
yeah.
body is constructed and we are just calling the body when needed.
So what actually in reality happens is the vector, let's say vector has a standard vector, right? So these functions are defined something like this. So imagine my function is the vector is one of the, okay, resize, right? So we have data, we have I think we saw the resize and everything. Imagine function is also a member data, like, or imagine this function is, it's not fn, it is resize. The header file will include just this. Imagine the commented parts are not there. Okay, that's it. It's just some kind of definition, like more like a declaration. And the actual definition is for every header file. It actually there is there in something called a shared object. Okay, so what G++ then does is, after it come it let's say you include standard vector, right? So standard library. So that's like this. That is actually the standard library. So standard libraries, if I want to access a certain function, let's say vector, I include its header file. Header file finds declaration like this. Okay, great. It's good to go. It will compile the code. Now, when it calls this function, okay, that function's body is there in something called shared object. Then comes the part which is called linking. When it's trying to link, the more functions it finds, it has to link them. It's already pre-compiled, which makes things faster. Sure, like I was saying, it has to compile all these functions. Let's say in practice, it doesn't need to, because it's already compiled, pre-compiled, right? But still, it has to link. Now then, linking will take some time. So to avoid all these unnecessary functions getting linked and bloating your object, the not the object file, the executable that you created, it's better to reduce it. That's the idea.
So basically, like space depends on header file, or like when we compile it depends on that.
Depends on your compilation. So you can have like okay, imagine this. So there are two kinds of build. So space, when you say space occupied by your executable, hello.
Hello.
Yeah, hi. What I'm asking is, do you mean, are you asking the space occupied by your
Like
executable?
executable file also, and like after making the program file, what is will be the actual space
Okay.
of
So
the original code, or like include or including the
include
header files also.
including the header files, and depending. So there are two kinds of builds also. When I say build, it's like the uh, formation of the executable. That's called a build. So when you create an executable, you can have two kinds of builds. One is called a static build. This is called a dynamic build, dynamic linking. Okay. So static, what happens is you when you include the header files, you have some pre-compiled. These functions are also pre-compiled. They're in some libraries. It's like some shared objects. Okay. You put that code also in your executable. That's called static building. It makes your executable much larger. It's huge. The other kind is dynamic linking, where let's say it just links it. So this shared object, let's say, is in some other path or some other place. When required, while compilation, you just give the path to it, and when required, it will see the it will get the body, the whatever code this function has, will call it appropriately. It makes your executable much lighter in space, like occupying. But the downside is that you can't cross-platform it, in the sense, if you have compiled it for some system, you can't transfer it to some other system, because it has dynamically linked a path, right? So in static build, that's not the issue, because all the required binary, all the required code, everything is inside that binary. So static is much larger, but it's transferable. Like don't have to link it again and again or anything. That's the idea. Yeah, that's so from perspective of even compilation, you can have uh, reduced code load by like doing a dynamic linking. Okay, I hope that is clear.
Is it possible to store header files in another data type and calling it when needed?
Yeah. So your question is you're
Like
having.
that's it. Like I asked earlier, why
Hmm.
can't we include all header files and call it at once? So it is possible to declare an header file at one place and then
Yeah.
call it in main when required. Like all
So
header files in one place and then we are
yeah,
calling it.
you can do that. So let's say you write your own hash include my header file. So let's say my header. Okay. Dot sorry, dot h. Ignores cookie line because it can't find it, so it's showing. Uh, but then inside that my header dot h, you have included all the header files that you want to access ever. Let's say there are 10 or 11 header files which you'll ever access. You can always include this file. Inside this file, have all the header files and then include this. Yeah, you can absolutely do that.
Okay, sir.
Yeah. One more thing I will what do you say? Point out is, so let's say I have included a header file, uh, something like my header, right? Or some file called q1.cpp. I can include even files also. Like essentially including a header file is, we call it a header file to be more specific, that it just has declarations, not the definition. That's the uh, mm, uh, small point, but the idea is that you can actually include any file. Okay. Now let's say I include q1.cpp, or in my header file, it has some header files, right? What if it has iostream or vectors? I've already included them, and when I include my header.h, it has iostream, and let's say it has vector. Won't it have clash? Yes, it actually will. So C++ actually doesn't allow that. So let's say q1.cpp also has iostream, and here I have iostream. Okay. C++ ideally doesn't allow same header files to be included. So then what happens? You have namespace clashing and all. So, but if you try to do this, it will be okay because of something called uh, where the standard itself takes care of it. So there is a thing called you can pragma ones. Okay. So what it does is, inside the IO stream, it's uh, this processor, this macro is used called hash pragma. Then like you have hash include, you'll have something like hash pragma, then once. So what this means, before the start of any header file. Okay, so let's say not even header file, any file. So if I have a file, I can just include hash pragma once, And what this means is, if I include this file any other time, it will not get included. It will only be included once. There are different ways of doing this. People use if defs. So there's called hash if def and something, and then if it is
Like
different.
sir,
Yeah.
what are you currently explaining? Can you tell me? Like I got
Yes.
disconnected.
Oh, sure, sure. So what I'm discussing is, so let's say I have my header.h, or I have q1.cpp, any file. Okay. It need not be just a header file, any file actually, like anything. Now, imagine that file includes a header file called iostream. Okay. And in my reference where I'm including it, it also has another header file. That is not allowed. Okay. In C++, you'll get linking errors. And again, C++ will throw errors. But the reason for that is, in iostream, let's say, imagine iostream has some header file. It has some functions. It has to create symbols for it. Symbols is like how compiler will know which function it is referring to. Okay. So it'll create some symbols, and my header file also, it has the same function. So then it doesn't know why do I have to create the same symbol for both of the same exact function, because they will be the exact function, right? C++ doesn't allow that. That will throw error. But you won't have trouble with it, trouble with including header files from standard library, because there's inbuilt something called a it's actually taken care of. Okay, there are two ways. One way is to use hash pragma once. Okay, so let's say I include a hash pragma once here. Oh, sorry. Uh, so what happens is, if I include this file inside this file reference.cpp here, like this here, what this will do is it will include all the lines. Okay, so let's say for header file and everything, but only once, whenever it might be called. So let's say iostream is called here, right? Because this is my main file I'm calling. Iostream will include only once, and when it is included, so see q1.cpp also includes iostream, right? This is not it right now. So it includes iostream. This iostream won't get included. So only code from line 3 to line 25 will get included when this is called. This line iostream, it's inside itself, because it knows that there will be, let's say, a pragma once, because iostream was included once before, it won't include it again. So there will be no clash. So standard libraries already take care of those things. But why am I even at all mentioning this thing is, when you write your custom functions, custom header files and everything, you have to take care of this. So it's a good practice to include hash pragma once in all header files, so that you won't have
Pragma, a keyword like
yes,
pragma or something like. What does it mean? Pragma.
yeah, yeah. So here, anything with a hash is called a macro. Hash include is a macro. Hash pragma once is also a macro. Think of it like these are more specific called preprocessors. So before even the program gets compiled, this something which has hash in hash anything will get executed first. Okay. Each of them have different function that is done by the compiler. So hash includes the whole file, you just copy pastes it. Hash pragma once takes care of just one thing, that whatever follows me will be included only once. That's it. That's the job of hash pragma once. People do use something like hash, then if def, yeah, if defs, and then something. But anyway, then end hash end defs. Yeah, hash if def, hash end if, yeah. They and then put the whole code inside. But in more modern compilers, you can do the same thing with just hash pragma once. And the nice thing is, this hash pragma once is already there inside this library, in this standard library header files. You don't have to worry about including iostream many times in many places and then trying to compile. It will include it only once in your whole code. Whenever the first IOStream is included, it will only get included there, like the first time, and then the rest every time, let's say you have it in q1.cpp or any other file, it doesn't matter. It will only get included once. Okay. I hope
Okay,
that is clear. Yeah. This is a again more on how do I say how C++ itself works. Yeah.
hello.
Yeah. Hi. You have more
Yes,
questions? Yeah.
yes, sir. Sir, but sir, like as you told, including header file doesn't, matlab, like it doesn't use any much space. Only it uses space on compile time, if I'm not wrong. So, what is the use of pragma once if header file doesn't acquiring any space?
Yeah, so the issue is that let's say you include some function inside, so IOStream has some function, right? Let's say it gets included again. While compilation, when the compiler is trying to compile, it will see some function inside IOStream. It will see the same function again. Now it doesn't know how to create symbols because it's exactly the same function. Okay, then that creates an issue. You can't have same different symbols. Like it will try to compile, right? So then it doesn't know how to create symbols. So definitions and functions, like any of them. So function, let's say void function integer pointer p has to be declared only once. You can't define it many times. Exactly what I'm saying. This is this exactly. You can overload it. That is okay. Like what I've done here. That is fine because it takes different um, attributes, different parameters. You'll have basically namespace collision. Anyway, this is um, something which since I was talking about header files and there are includes and all, so I just discussed. But essentially, for when you're using standard libraries, you don't have to worry about calling the same, uh, like including the same header file many times. Okay.
Okay, thank you, sir. Thank you.
Yeah, sure. Okay. Uh, if people have, anyone has more questions, any other question? Okay. Maybe we can then continue. There was,
Hello.
yeah, hi.
So,
Yeah.
like some programming language like Python and
Mm.
other language have less code while compared to C. Like if
Yes.
we see
Yes.
C has
So many
C has
lines.
also, so why C is fast if C has large code like
Large code, like, yeah. So the reason for
why
that is
C++
again
is considered fast if C++
first, yeah, yeah,
yes.
right. Again, like I said, the answer goes back to garbage collection. So essentially, it is memory management. You might see it's a lot of code. Let's say the same code will be just one function in Python. At the back end, it will be also a lot of code that it doesn't exactly show up. Anyway, the point is why is even C++ fast, right? So it's not due to the length of the code. It's more like what you do with it. So in Python, you don't have to define data type. So let's say I have complex data type. Here I've defined. Here it knows that when I declare an object, it will store double, real, two doubles, and some memory for the functions. That's it. The great thing about C++ for this part is even if you don't declare any object or don't use it also, it knows exactly how much amount of memory it has to store for every object for every object created under a complex class. Because you define everything, you have to define all the variables, right? Double. So it knows it will have 8-byte memory for these 8-byte for each of these 8-byte return will be there, and whatever memory it has to store for this. So everything, it's like while compilation itself, it knows everything. But in Python, it's not the case. When your program can itself change the data type dynamically, you can have very weird data types. One time it could be integer, one time it could be a very huge class, the same variable. So Python has to take care of that movement. That movement is what is the cost. That internally it has to know which the variable is referring to what memory and all. That is the main difference. That the difference is that in C++ is already known to like to a large extent what the data type is. I wouldn't say to a large extent, it's like exactly known. Now it might not seem like it, but one of the costliest thing in programming is data movement. So when you're trying to access some data from RAM and again writing it back, moving data from one location in RAM to again another location in RAM, there's actually in the scheme of running a program, if you do it too large number of times, it becomes expensive. That's what Python does. That's what its garbage collection, which is built into the Python language does. Yeah. But in C++, because you have the control and you are expected to most of the uh, no, you are expected to define everything. Compiler knows it, like how much memory to do and all. Again, the nice thing about C++ is it takes care of the deletion part, like I said, some memory management. So in a way, you get some benefits of Python also, in a way, in C++, without
And also
losing.
like instead of using delete in C++,
Yeah,
what if we point that reference to null? Will it get deleted by garbage collector automatically, or it
no,
will get stayed in the uh,
it will be there.
store
So
memory?
your programming will end, but what you did was, let's say it was pointing to some actual memory. Now it is not. That is not good because the OS will still think the program is using that portion of memory while it is actually not using, and the program has ended.
But
So
like
you,
if any
Mhm.
any reference is not pointing to that that
Mhm.
storage, that memory, it
Mhm.
will automatically get
Deleted.
removed by garbage collector if I'm not wrong.
Yes, in Python, because Python has a garbage collector. In C++, there is no garbage collector.
Okay. So like we have to
Explicit.
define that. Okay,
Yeah, you have to explicitly do it.
okay, sir.
Yeah,
Thank you.
yeah.
So in a program, like if we don't delete a memory and just close the program file, will it get deleted from the memory, or like something
Oh,
like it gets piled up again
it
and
gets
again?
piled up. It actually gets piled up. To some extent, if the program ends, I think the operating system has gotten smart that since the program has ended, I should free up this memory or something. But ideally, I would say it's not a good practice. Okay, because in modern OSs and all, if they see some program like written by C or C++, if they see the program itself has ended. So think of it like when you run a program, it has a process associated with it. Okay. So now inside that process, we'll have memory, like this memory, that memory, right? Uh, I defined for reference, right? So it has vector memory and all. You can have using new also. Now the issue is my program, which has a like there's a processor associated with it. Process, not processor, process. It will have memory of new with some pointer. Okay. But if you did not do delete, that memory will still be occupied and the OS will still like that. Probably in modern systems, it doesn't happen, but in general, it will still think that that memory is occupied, even if the program has ended. Probably I'm not entirely sure, but I think in modern systems, you have when a process gets like done. So let's say this code is already run its course. Then once the process ends, the OS will probably free up the memory. But again, it's not a good practice to do because you don't know what system your code is going to run, right? So assumptions like that should not be made. That yeah, even if I don't delete it, probably my OS will take care of it or something. It's not at all a good practice. Even better, actually, you don't have to do a new and delete. because there is a much better way of doing it in C++. You just use the standard vector or all, because you don't have to even worry about creating and how much space you want. You just call the resize function, it automatically takes care of the creation. And you don't have to delete it because this object, once it goes out of scope, its destructor gets created. And when the destructor gets created, all the memory is already automatically freed. So that automatic garbage collection is in a way inbuilt into C++ using the destructor of the classes. Okay, I hope that is clear.
Okay, sir.
Yeah. If anyone has any more questions, I can take. Yeah, like, so to summarize a bit, um, C++ itself has been for a very long time, like around, right? It has its own inner workings, how compilation, what steps happen, during runtime, what happens, uh, like various aspects to it. It's an interesting read. You can probably find some of the portions in the lectures itself. Here, I would actually definitely encourage if you're more interested in knowing actually how the program evolves, right? What stack pointer happen, like how what's thing called this stack pointer, right? What's this heap allocation? Um, what's this? What is this thing about scope, global scope, local scope, so on? Feel free to explore more. I can also discuss, like I was, few these classes also I discussed again today also. I'm more than happy to discuss again also, but like these are some um, topics that I highly encourage to know, even if you don't need to know to write codes, because uh, since I'm writing C++ and uh, to some extent you don't need to know all this, sure, but it helps in writing better code. Yeah, so hence I do definitely encourage these aspects also. I understand this is not the part of the course also. So here the focus is to already sort of assumes you know programming, but going into deep of certain aspects of the programming, because hence the T session you can ask me these questions. So yeah. Yeah, like I was saying, so I definitely encourage to learn about these things, because once you know the more inner workings, essentially that's the idea of C++ also. So because you have so much control over how your program actually works, knowing the more in a way to the depth, it helps you even write much faster code, and you can do some optimizations and then uh, keep certain things in mind. Okay, I know my code is running uh, with taking certain time. This is the bottleneck I have, because I can optimize certain way. Yeah, so that is from the perspective of optimizing and getting more performance out of your code. So learning this aspects also helps in that, but if the goal is to just write code and get the answers, then probably it doesn't matter. Yeah,
Thank you, sir.
yeah, sure. Maybe before closing out, I'd like to mention one more thing. In the first class, I showed how to even write some basic code and then compile the code. You can use different standards there. Maybe you guys can take a look. These previous lectures, previous TA sessions. Uh, so that should get you at least started. So that was the main idea behind the first class also itself. Um, if you have any specific topics you want me to cover, also you can ask me during these sessions. Um, yeah, I'll continue with the classes, the other aspects about the uh, class itself, the this class. Yeah, from next class. Yeah, next session. I mean, okay. Okay, I guess with this we can end the today's class. Yeah. Thank you everyone for joining, and hope you enjoyed today's class too. Yeah. I'll spend more time on object-oriented programming only because this is actually the heart of C++. So we'll continue this next session also. Yeah. Okay. Thank you. Yeah. Thank you.